I'm going to try to finish up chapter 16 with this recording, and hopefully it won't even be very long. A little bit about carbohydrate digestion and absorption is that carbohydrate digestion begins in the mouth during mastication or chewing. Salivary amylase breaks down complex carbohydrates like starch into larger sugar molecules. Pancreatic amylase in the small intestine continues breaking down carbohydrates into sugars. And then also the brush border enzymes will break down carbohydrates into monosaccharides. So lipids, lipid digestion involves the enzyme lingual lipase from the mouth, from the salivary glands, and pancreatic lipase from the pancreas. Another component of lipid digestion is that bile salts will emulsify fat droplets. All right, so there are two stages in as far as what happens in the digestion of fats and the movement of those fats into the lacteals, into the lymphatic system before they're eventually, the products of that digestion enter into the left subclavian vein. So the first thing is that triglycerides is just another name for fats, are broken down into fatty acids and monoglycerides. And they combine with bile salts to form micelles. And this, micelles is how you say that. And this happens inside the lumen of the intestine, the small intestine. Then once those micelles are coated with proteins, we call them chylomicrons. And the chylomicrons, which is basically fat, bile salts, and proteins, is absorbed into the lacteals, transported into the from the lymphatic system into the venous system, empties into the veins at the left subclavian vein. So this just keeps the fats from entering into the bloodstream until they've been fully broken down. This is more notes on the enzymes that break down proteins. So we're going to move on past that. So this is a figure that covers the breakdown of carbohydrates, lipids, and proteins. And again, we've already talked about all of this. So I'm not going to go into this a lot of detail with this figure, but it's slide number 105 if you want to review it yourself. For the absorption of vitamins, there are two types. There are fat-soluble vitamins, and then there are water-soluble vitamins. So the fat-soluble vitamins are vitamins A, D, E, and K. They are absorbed from micelles along with lipids, and one of these vitamins, vitamin K, is produced by the bacteria in the colon. So these are fat-soluble vitamins, and then water-soluble vitamins are the B vitamins and the C vitamins. All of these except for B12, which remember is requires intrinsic factor to be absorbed. So all of these B and C vitamins are easily absorbed, except for B12, which requires intrinsic factor. And there are some gut bacteria that produce water-soluble vitamins as well. Remember, we said biotin or vitamin B7, and then also vitamin B5. So how does this relate to anything? I mean, what does this matter? If it's fat-soluble, you can overdose on it. If it's water-soluble, you don't tend to have too much of it because you can excrete it with your urine. So you have to be very careful about how much vitamin A, D, E, and K that you get. A lot of people take vitamin D supplements and vitamin E supplements, but especially vitamin D. And with women, women tend to, as they get older, have low levels of vitamin D. And nothing's wrong with supplements. You just have to be aware that you can take too much. So be very aware of what you're getting in your diet and what how much you're taking in the supplementation. All right, checkpoint question 23. What component of food would increase the number of chylomicrons in the lacteals? Well, it would be lipids. Removal of the stomach would, well, I would say lipids and proteins, because chylomicrons are lipids with proteins attached. So you'd have to be able to eat proteins for your body to make proteins to form the chylomicrons. But I think what the question is asking is simpler than that. I think it's just asking you to know that it's fat. Removal of the stomach would impair the absorption of which vitamin? And that would be vitamin B12, because not that vitamin B12 is absorbed through the stomach, but it's because the stomach produces intrinsic factor, which is required for the absorption of vitamin B12. Without the stomach, you wouldn't have intrinsic factor, so vitamin B12 wouldn't be absorbed. 25. Why is it that diarrhea is potentially life-threatening, but constipation is not? So diarrhea can lead to severe dehydration, and also it can lead to a condition called alkalosis, which is when your blood pH rises too high. It's opposite of a condition called acidosis. So diarrhea is much more dangerous, faster anyway, than what constipation is. Age-related changes. All right, you're more likely to get peptic ulcers, more likely to get hemorrhoids, because older people tend to be constipated, so straining leads to hemorrhoids. They are more likely to have heartburn due to the weakening lower esophageal sphincter or cardiac sphincter. Other things that can weaken that sphincter, by the way, and cause heartburn are caffeine and smoking. Both of those activities can weaken that sphincter, and so people who smoke and drink a lot of caffeine, they might have heartburn associated with that. Cumulative damage becomes apparent, so they end up having more dental caries or cavities, and gingivitis or inflammation of the gums. Cirrhosis or other liver disease just tends to increase with age. And then there's a question on the quiz. There's a quiz question about why does the cancer rate increase in older people? And that is going to have to do with well, actually, that has more to do with the lymphatic system. We're going to go over that question is in chapter 14. I apologize. For right now, just know that the cancer rate increases in the elderly, and dehydration increases in the elderly, because the receptors for water, those receptors' sensitivity declines, so they don't absorb as much water as they should. So they're going to have problems with constipation, but also with diarrhea. So problems with all body systems as we get older. But these are just a few of the problems with the digestive